Sometimes when replacing a module on a vehicle, you need to reinitialize it to the system. Let's walk through how to do that on an example 2023 Ford Bronco. So for this example, we'll use a LIN Bus module coming out of the body control module. So we'll scroll down here till we get to the body control module. It should be under body. And you see in the body control module, we have codes, data, functional tests. So it is a functional test, and it would be considered a special function. And then we can see right there, second from the bottom, LIN new module initialization. This procedure will configure all BCM LIN nodes such as the rear view camera, intrusion sensor, rain sensor module, and battery monitoring system. After you select OK, some nodes might go into configuration mode. So you continue. You're going to need to turn the ignition switch on. And then it will go through about a 15-second countdown, reinitialize the modules, and it will tell you when it's complete. There I am. All right. Good evening. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just make sure you find the Zoom controls top or bottom of your screen, little Q&A button. Click on that, type in your question, and I'll get to that in a minute at the end. If you're watching along on YouTube, feel free to use the live chat function with it, and I will get to those questions at the end as well. So my name is Jason Gabrinas. I'm the Technical Training Manager for Snap-on Tools and Snap-on Diagnostics. Been in the training department the last 13 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so worked in a dealership and just over time became that default diag guy in the shop. So I was ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. And before that, bunch of other miscellaneous wrenching jobs. Been about 30 years plus under hood experience for me. So our topic today is kind of a twofer. So LIN Bus is going to be the front half. We're going to talk about LIN Bus, what it is, how it works. And then it is very directly related to initializing new modules. So we will talk about all the different ways that we can initialize a new module. So it's kind of like a twofer, but they are very interrelated and very tied together. Pardon me 1 second. Keeps flashing in the back of my background. It's distracting me. All right. So first up is LIN Bus. So let's talk about what LIN Bus is. So it is a network protocol that would be used on automotive applications, other applications too, I'm sure as well. But LIN Bus in our world is going to pop up on automotive applications, of course. So it is a network. So in that case, it works on what they call a voltage differential. So the difference between the top and the bottom, that's where your data packet lies. And that's your ones and zeros on the vehicle. So in this case, we see the top of this square wave is at 13.35 volts. This is a battery monitoring sensor on a Subaru. So 13.35 volts on the top, vehicle's running at the time. And then down here at the bottom, we see 0.91. This gives us 12.44 volts. This works on a 12-volt differential. So anywhere in that 12-volt-ish range, give or take tenths of a volt on either side, half a volt maybe. It is considered valid signal. If it was too small, then it would not be considered a valid signal. It needs to reach a certain threshold of voltage in order for it to be considered valid. So just like any other network, it sends its ones and zeros using a voltage differential. Now, LIN was specially developed to achieve cost-effective communication for intelligent sensors and actuators in motor vehicles. So it actually stands for Local Interconnect Network. So it consists of a single wire with a transmission rate of up to 20 kilobits per second, and it uses a 12-volt differential, like I just said. It is a master controller and a slave controller. You can actually have multiple slave controllers off of it. You also may now hear they're kind of changing the verbiage when referring to these modules sometimes. So it could be also referred to as commander and responder, right? It's the one sending the commands and the one responding to the commands. So it's set up something like this. So I'll have a master controller, and then a bunch of receiver controllers down the other end. Can be up to 12 total on the system there. So it's just they can kind of branch off. We'll see a couple wiring diagrams a little bit later, but that's kind of what we're talking about. So it's things like roof sensors, light sensors, sunroof controls, steering wheel controls. A lot of the buttons that are on your steering wheel now for all the things operate over a LIN bus. Seat position motors. We're going to look into one of those in a little bit. Engine, small sensors, small motors, grill shutters. Small motors in the climate, your blend door actuators and things like that. The control panel itself might send signals over a LIN. Same thing with doors. Like a door could be an entire just LIN network in there with your master buttons controlling all the motors and mirrors and stuff like that. So here's an example on some LIN applications. So a driver seat adjuster switch, I believe this is on a Cadillac we're going to look at a little bit later. Ground is supplied at all times to the seat adjuster switch. Battery positive voltage is supplied at all times to the seat adjuster switch through a 10 amp fuse located in the fuse box. When the seat adjuster switches are pressed, the appropriate signal message is sent to the seat memory control module via a LIN message. The seat memory control module then commands the appropriate seat motor to move in response to the switch signal message. The front seat adjuster switch would be the passenger side. Ground is supplied at all times. Battery positive is supplied at all times. Same idea as the driver's side. And then for lumbar support, seat switch communicates all customer requests for seat movement or adjustment via the LIN serial data bus to the seat adjuster memory module. Seat switch may consist of the following controls. Seat adjuster switch similar to the typical discrete seat switch. Two-way lumbar switch, which can be activated forward and rearward, and two-way bolster switch, which can be activated up or down. Manipulating the seat cushion and seat back control bar results in the seat memory control module responding the same way as it would if the resultant requests were made by discrete signals instead of the LIN messaging as this switch employs. So instead of sending a direct signal to the module, it sends it over the bus. So in this case, we have the switch sending the commands. Then that signal goes to the control module, and then the control module tells whatever motor what it needs to do in that case, right? So it sends a signal over LIN to this. This sends the output over LIN to whatever motor it needs and tells it to go either front or back. It's not a lot of, I guess it gets rid of a lot of the relays and the direct wires and all of that. So I guess it simplifies vehicle wiring in that way. But it can make it a little more complex, like on the back end, the software side of things. So it's kind of a trade-off, I suppose. And like I said, this is a typical LIN signal that you're going to see at your ones and zeros, right? So it's typically pulls down for a 1 and up for a 0. So in this case, we see a lot of 1s and 0s, and then we have multiple 1s here and a lot of 1s there. So depending on what the signal is, it just kind of pulls it down or up, depending on whether it needs to send a 1 or a 0. Since it is a computer, it speaks in binary and it only knows 1s and 0s and combinations of those. So this would be considered a data packet, sending data to the computer, whatever it needs to do. All right, so that's LIN. Not a half hour worth of content to talk about that because we're not electronics engineers. We don't need to know about all the other ins and outs of coding and stuff like that on the bus. So that's basically how it works. And I feel as a technician, that's really all I need to know is how it works. It sends a signal over a bus, and then it goes to the individual modules that are connected to it, and master and slave type situation. But that ties into new module initialization. When I replace a module on a vehicle, I need to do one of these 5 things mainly. I'm sure there might be something else that might fall under one of these categories, but I think pretty much anything that we need to do to set up a module or initialize a module or what have you falls under these 5 things, right? Resets, relearns, coding, programming, and flashing or reflashing, depending on the operation that you're doing. Now, I will say a lot of these terms tend to get conflated in the industry. OEMs are just as guilty of this as aftermarket. But I'm going to try and at least, so we're all talking the same language or we're talking from the same place. Let's try and just define these generally so that we can kind of understand, what we're talking about when we're talking about it. So first one's resets, and they're used to reset a parameter back to factory specs. For example, oxygen sensor heater. So on a GM vehicle where the oxygen sensor heater changes, it learns the pulse width that it should be pulsing for the oxygen sensor heater to get it to heat up right. It learns that when I replace that, I need to reset it. Transmission shift adapters. Most modern transmissions learn how you drive. And when you do any transmission work, you need to reset it back. Otherwise, you might have harsh shifts, things like that. So those are a couple examples of that. And one good place to find a full list of these, and we'll talk more about this as we go, if you have a snap-on scan tool with the service resets and relearns menu, you can go in there and you can look and say, oh, did I do one of these jobs? It's going to go through by job, and it's going to say, okay, have I done this job? So for example, relearn the oxygen sensor that I just talked about. So if I go in there, it's going to pull any resets, relearns, or bidirectional controls that I might need for that. Also going to pull any TSBs related to it and any top repairs data based on that. So in this case, we want to relearn the oxygen sensor. So we'll go to heated oxygen sensor heater learn. It's going to say on the next screen, select reset. So we'll do that. And then it's just a little checkbox. You hit reset and it brings it back to 0. And then you start over and everybody learns where they need to go. If I didn't replace all the oxygen sensors, maybe I just replaced one, all the other ones will learn back to where they need to be as well. And that's as simple as pressing a button on a screen. Very easy. All right, next one's relearns. So this is similar, but relearns are used to teach the ECM parameters of a replacement part. So every part is going to be slightly different based on design tolerances. How many windings are in that motor? How many windings are in this injector? How much voltage is being applied, etc. So one very common one is throttle body relearn. I replace a throttle body on a vehicle. It needs to relearn what positions are where. What do I need to? What kind of voltage do I need to send to it to open it and close it? Valve body relearn. I replace solenoids in a valve body. It needs to relearn the parameters of those. TPMS is a relearn, right? It needs to know what corner of the vehicle it's on based on its signal number, right? So once again, we'll go into service resets. And then in this case, we're on a 2012 Nissan Murano. Very, very popular is the idle learn procedure after I relearn a throttle body. And then the idle air volume learn is there. Now, I will say that on many relearns, not so much resets, but definitely on relearns, on a lot of vehicles, there may be parameters that need to be followed. So in this case, idle air volume learning is a function to learn the idle air volume that keeps the engine idle speed within a specific range. Needs to be done each time the idle air control valve, throttle body, or ECM is replaced. Idle speed or ignition time is out of specifications. So we need to do all of this first. So perform the accelerator pedal release position learning. Make sure the accelerator pedal is fully released. Turn the ignition switch on for 2 seconds, off for 10, on for 2, off for 10. Then we'll hit continue. Throttle valve close position learning. Accelerator fully released, on, and then off. And then confirm the operating sound of the throttle valve during 10 seconds. So you should hear it open and close. Go through that. Before performing the idle air volume learn, make sure all the following conditions are satisfied. Learning will be canceled if any of the following conditions are missed for even a moment. Remember this. We get tons of phone calls every single day. People trying to do relearns and one of the parameters goes off, right? So for example, needs to be more than 12.9 volts at idle. Drops to 12.8. Shuts it off. Stops the relearn procedure. Coolant temperature, 70 to 100 Celsius or 158 to 212 degrees Fahrenheit. If it hits 213, done. Stops. Right? These are the parameters that they're telling you. Now, I will say, not every manufacturer is very good about figuring out what these parameters are and telling you what these parameters are. But if we have them available, we will put them in the tool in line with the test. Or it could also be in service information. Or it could be in both places. But just remember, and this is not just exclusive to this test. This one seems to struggle a bit because of so many parameters, but always make sure when you're doing any sort of functional test, relearn, reset, calibration, that sort of thing, follow the instructions to the T, right? So continue through that. If all conditions are met, key on engine running, select continue, it'll start the test. And it goes in, does the test, gives you a success screen when it's done. Or it'll give you a failure code if it fails. Next one's coding. So coding is also a teaching procedure, and it will teach the ECM parameters by using a code number. One very common example is fuel injector coding. If I replace a fuel injector on most direct injection vehicles, be it gasoline or diesel, I probably need to code that injector to the vehicle. Another one is like headlight coding on a Mercedes, or the LED headlights, the matrix headlights. You have to code those. There's a code number on them. Proxy alignment's another one for like Fiat vehicles, right? So when you replace anything in the system, this needs to be done. So the BCM stores and compares vehicle configuration data with the instrument cluster, as well as with other electronic control units in the vehicle. This process is referred to as programming of configuration of systems integrated, or proxy, also known as proxy with an X. If a configuration mismatch is detected, BCM sets a code. Configuration mismatch code will require the performance of a restore BCM proxy configuration routine or a proxy configuration alignment routine using a diagnostic scan tool. All right, so I'm not going to read through the rest of that because it is readily available on the scan tool. As a matter of fact, it actually is its own button. So you got BCM, and then you got the proxy alignment right there on the front screen. Perform proxy alignment procedure. Procedures use to display the proxy configuration status of the entire vehicle and copy the proxy configuration data to any required ECUs. Continue to display the current vehicle status. In this case, 2 of them are unknown. 2 of them are all set. So in this case, it's going to make sure everybody's got the right configuration in there. Complete the process. Turn the ignition off. Wait for the countdown timer to finish. And then it's done, right? That's a simple coding. Otherwise, if you do like a fuel injector on a Ford diesel, it's got a code number on the top. You got to punch it into the tool in order to tell the computer how much fuel to flow at how much time. Right? Now we get into where it could get a little bit confusing, especially with some OEMs like to do this too. Basically, the next couple things I'm going to talk about can be conflated as each other, and they are often conflated with each other, OEMs and aftermarket. So programming is used to change the ECM parameters. For example, I have a vehicle and I want all the doors to unlock when I press the fob once, or just the driver's door to unlock when I press it once. Answer back alarm, chirp or not, right? Turn these things off. Often very common in the BCM. I've seen them in other modules, but very common for the BCM. So for example, I've got a Subaru Forester here in body control module. How long do I want it before it auto locks? So in this case, it's set to 0 seconds. We'll hit edit. We go in here. I want to change it to 20 seconds. Hit program. Got 20 seconds there. Hit program again. And then it'll program that into the BCU or BIU in this case. And then the auto lock time will then be 20 seconds. Auto light sensitivity, remote trunk opener, power rear gate. Power rear gate setting, whether or not it has it. What's the market for the vehicle? Is it US? Is it UK? Whatever. So there's all sorts of different things that you may need to set up or be able to set up when you put a new module in. And then last we come to flashing or reflashing, depending on how many times you've done this procedure. So flashing is used to write software to the ECM. That's what it does. So for example, replacement of a blank module. So if I order a PCM from a Jeep, it's blank. It has no software on it to run it. All the chips and resistors and everything else are there, but it has no software to run it. So you have to download that software from the manufacturer's website and then flash it to the chip inside the computer. That's where it comes from. This comes from way back. 80s, probably even earlier than that. Flash ROM is what it was called, right? Read-only memory. And you could flash the program to it, the instructions, the code, right? You're flashing it to the piece of silicon is basically the way it boils down to. So that's where the word where flashing came from. Now, reflashing would be like a software calibration change. Oftentimes, a manufacturer will call it that, but that's taking something that already has software on it and doing a software update. So that's reflashing. So I flash it again to the chip, right? So flashing and reflashing are pretty much the same thing. It just depends on what step in the process you're in. What do I need for this? Well, I am not doing with an Android tablet, I'll tell you that. I need a Windows PC, usually Windows 10. Some manufacturers are up to Windows 11 now, but not everybody's on the same page yet. So I do need a Windows PC. I need a pass-through device of some sort. There's a few of them out there on the market. They're all pretty much made by the same company. So take your pick. They're all pretty much the same price as well. Also need a good internet connection because you need to download the files. And you also need a good battery maintainer, not a battery charger. It needs to be something that holds a steady state voltage that's not going to spike. If you have any voltage spikes when you're doing this procedure, some vehicles are more sensitive than others, but you need to make sure it is a nice, steady, clean voltage signal. So in the case of this one, the BEBC 500B, I believe we're up to now, that puts out 14.2 volts steady signal, and it is is available at 90 amps current available, and that's a spec for a BMW needs that. So it is good for that. We also have another tool called the EEBC Flash, which is specifically made for Flash programming. Also need an account with the manufacturer. I do need to update this chart because they got rid of the NERS software, so now they're on a day, month, year type of scheme with Infiniti and Nissan as well. But these numbers are fairly close to what everybody's at. BMW, it's $32 a day, $270 a month, $2,700 a year, right? And you get dealer level diagnostics, and it does all modules, excluding most network modules, which most would be the media-oriented systems transport. Totally different network. I talk about it in one of my other network videos. You can look it up if you want. Sometimes they, actually, yeah, that's gone. The per flash on Nissan's gone. Kia and Hyundai, it's $75 a flash. So the software is free. You just pay for the flashing of that vehicle. Dealer level diagnostics, ECM and TCM, flashing. So all the manufacturers vary greatly. Mercedes 63,303, 3,253 a year. How about Volvo? $6,500 a year. So allows you to flash all modules and get dealer level programming or dealer level diagnostics. But if you want all these manufacturers, you got to pay, right? And then here's an example of system requirements from Ford. So Windows 10 Professional, IE11, Microsoft Edge, 4 gigs of RAM. This is the recommended setup down here. Also says Windows 7 and 8.1 updating to Windows 10 is not supported. So there must be some key component of Windows 10 that is not there when you upgrade from 7 or 8. So my studio computer wouldn't work with that, because I've been upgrading it over and over again. Another fun thing is, for example, Mazda and Ford don't play nice on the same computer. So you're going to want to do separate partitions for it, or even a separate computer. So there's a lot of different things that you need to be aware of, and setup-wise that you need to be aware of. So if that's the road you want to go down, which you need to make sure you read everything carefully and follow instructions and all that. But if you don't want to do that and you want somebody else to do it for you, there's also something available called the Pass-Through Assistant. So these are the supported brands on this. So any of these vehicle manufacturers, I can plug this box in, make an appointment, they'll call me, and they will flash it remotely for me, right? They might have to call you back, turn the key on, stuff like that. Just be available, but it does have a battery maintainer in it. Once again, 90 amps. You just hook it up with jumper cables, you plug it into the wall, you plug it in the car, you fire up, it's got a Windows 10 tablet in there, and it's got a Pass-Through Pro underneath. So it's got everything you need kind of all in one box though. So you bring it out to the car, follow the instructions, and they will remotely flash it for you, right? Also included with that now is repair guidance. So there's also a system we've developed in partnership with Opus, who makes these for us. But it's called repair guidance. So what it is using that same box, I can choose repair guidance, and that there are factory certified techs on the other end of the phone that will walk you through whatever you might need to do on a tough diagnostic thing. So one example, I was talking to a guy who's one of the BMW techs there, and he said, yeah, there's like here's an example of the things that we do. So customer calls in, whatever the problem was, I've tried this, 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 and this. What do I do? And then they'll prescribe a plan to go and attack it. And he said in this example is like, oh yeah, I've seen that 1,000 times. Go down on the passenger side carpet, pull it back, you'll find this connector there, look for water intrusion or whatever it happened to be, right? So this is that like internal knowledge that you gain after being a tech for so many years and working on the same vehicles over and over and over and over again. I'm like, it was a long time when I was in the dealerships where I could tear down and rebuild an engine on a Subaru in like, a couple hours because you know where all the bolts go and you know how to put it back together and take it apart because you've done it a million times. So it's stuff like that. Or like, oh yeah, I've seen this problem. That's a very common, just test this connector and see if it's bad. That sort of thing. So they are OE trained brand specific master technicians, and it's only $50 a VIN for 2 weeks. So if you're a shop owner and you don't have an A-Tech, or your A-Tech struggling, could be that too. But for $50, they'll stick with you for that vehicle until it's repaired, or 14 days. After the 14 days, you just re-up and pay again, right? So that's a pretty cool function, I think, as well. So they will help with flashing. They will help with repair guidance. Notice how the fewer vehicles supported for flashing, and that's just because of the licensing agreements they have with the manufacturers. Some OEMs don't like remote flashing on their vehicles, so that's probably another reason some of them aren't supported as well. But this is the ones they have master techs on staff to talk about. So Porsche, Jaguar, Land Rover, all these different OEMs, they will be there, and they are at your beck and call for, like I said, $50 for 14 days. How could you possibly go wrong with that? I just think it's pretty smoking deal. All right, let's go live and talk about a couple things. First one I want to do is look at the Cadillac and go into ShopKey and look at the seat. And so we'll do seat motor. Oops. Seat motor. And then wiring diagram, right? So you can go in here. We see the switch. And then we see the lumbar motor. Passenger lumbar motor there. Switch to motor. And then there's the seat control module. So this is on ones with LIN. So a 4-way one's going to have LIN. And you're going to see different signals going in there. And then here's another one, right? So that's LIN Bus right there. Driver seat memory control module, LIN Bus right there. Driver front seat adjuster switch goes off the LIN Bus as well. So signal goes over LIN Bus to memory control module. Right? Now, another good way to find out what systems are LIN on a vehicle. Now, this isn't on every manufacturer because not every manufacturer gives us this information, but you might be able to tell other ways. But in this case, if you have like ShopKey or Mitchell, you can go to computer data lines, and then that will bring you all of the different buses on there. So you can see like CAN bus, Ethernet bus on this one, private serial data, Ethernet again, Ethernet, and that's all in the serial gateway module. If I come down here, there's my seat control module, right? And we talked about that. And then there's a couple LINs right there. LIN Bus 2, LIN Bus 2, LIN Bus 1. So the different LIN buses go off of there, and they're labeled. So that's nice. This is CAN bus, LIN bus, all kind of mixed together in this module. So it's able to translate it. So steering column, tilt wheel, and telescope control module goes off of that as well. Passenger seat, and the memory module for that as well. So we can see all these different LIN. And of course, in this case with GM, they color them all green, which is nice. So easy to kind of tell apart. CAN is blue and white. LIN is green. So let's see, more LIN bus over here, right? Virtual key module, LIN bus. All of those things. That's a parking assist sensor, I guess. So that's just looking at the wiring diagrams, I can tell. I can also go in here in the scanner. Let's see what else we can reset or relearn on this. And let's just go into engine. And then look under special functions, learns and resets. And there we go. So ambient air temperature calculation reset. Got to do a reset. Air cleaner monitor setup. Crank position variation learn. So that's a relearn. That's a reset. Engine block coolant valve position learn. Engine coolant control valve learn. Fuel pump trim reset. Fuel pump power control module configuration. What's that we got? Oh, it shows that's a reset. Right? Fuel trim reset again. Throttle body idle airflow compensation reset. So that'd be on your if you replace the throttle body. Turbocharger wastegate learn. If you have a problem with a wastegate or need to relearn a wastegate, it's in there, right? So that's that. Let's go into my vehicle. And we'll do another example. So like on this Bronco Sport, right? That has a LIN module relearn. So bringing it all together here. So if I go down to the body controls, body control module, and come in here, and we should have on a functional test, special functions. We have LIN new module initialization, right? So this procedure will configure all BCM LIN nodes, such as a rear view camera, intrusion sensor, rain sensor module, and battery monitoring system. After you select OK, some nodes might go into config mode. It'll continue, turn the ignition on, and then it's going to do its little routine. It's going to take about 15 seconds. Goes through the thing, and then it tells you when it's done. Easy enough. Going to take about 15 seconds on the screen, and then it's going to hang for about another 5 seconds or so. Maybe 10 seconds. There it goes. Procedure successful. Done. So that's just a simple, make sure everybody's got the right stuff going where it needs to go. Battery monitoring system reset, TPMS training mode. That's also like a relearn, right? Programmable module installation. So lots of things available in those cases. I got one more. It's BMW. On this BMW, let's go into, in this time we'll go into service resets, right? So you go to service resets, it's going to give you all your maintenance type stuff up here. So for example, if I wanted to replace the battery on this thing, did I replace the battery? Yes. Okay, great. Are there any resets, calibrations that I need to do? Are there any TSBs? There's a couple TSBs on there. Battery total discharge, right? Functional resets and calibrations will pull back any of the functional resets and calibrations I need for this particular problem. In this case, we'll go to battery replacement. And there's certain things we need to do. So display distance reading at last battery exchange and one before last, register battery exchange, and end the service function. So I'm not sure how far I can go in here. We need to go in and change the battery type, and then it just resets it. Okay. So I'm just going to end the service function. Sometimes, like on a Volkswagen, for example, you need to enter the number that's on the battery into the system in order to register that battery got replaced. Now, this is very helpful. The service resets menu is very helpful for things like that. So, for example, we had somebody call in tech support one day a few weeks ago, and they said, hey, why can't I reset the battery on this Volkswagen? I don't remember what kind of Volkswagen it was. I don't remember the year. I'd show it to you if I remembered. But on this Volkswagen, they went looking in the engine, and they said, hey, I can't find the battery reset where it usually is on most Volkswagens in the engine. On this particular vehicle, it's in the central gateway. So they didn't look in the central gateway because they didn't know it was in the central gateway module. So if we had done it through service resets, it would have pulled that reset out of the central gateway and it wouldn't have to go looking for it. So that's one of the beauties of having this service resets menu, is it's not like we're hiding any resets, relearns. We don't keep them all in here, so to say. We actually go in and pull them from the corresponding modules that you already have access to on the car, and then just bring them forward to you, because it could be a reset or relearn that needs to be done on multiple modules. Brake pedal position sensor on a GM is a good example of that. Got to be reset in the engine and the BCM. If you only do one and not the other, you'll get a code, right? You'll get a failure. So this will save you time when it comes to resetting, recalibrating, reinitializing things, right? So that is LIN and new module calibration, right? Kind of gets your two for tonight. Let's talk about what we're going to talk about next week before we get to questions. So next week is going to be body shop scanner functions. Haven't taught body shop in quite some time, so I'm sure the state of things has changed a little bit since the last time I talked about it. So we're going to go through it. Talk about why body shops need scanners, some specific scanner functions that might apply very well to a body shop. So if you're interested in any of that, maybe sublet work for a body shop as well. It doesn't have to be a body shop. 6 to 9 Eastern, as always. Go to snapon.com/OT if you want to join on Zoom. Otherwise, the 6 p.m. Eastern class goes live to YouTube. It's youtube.com/SnapOnDiagnostics. And then the 9 p.m. Eastern class goes live to our Facebook page. On Facebook, it is Snap-on Diagnostics Product and Training. So make sure you check that out. If you want to see any of the other episodes in this series, we have 131 episodes so far. They're all archived on our YouTube channel. Scan that QR code right there. It'll bring you to the channel. Make sure you like and subscribe if you could, please. It definitely helps us out. We have been doing a lot of research on our videos and who watches our videos. More people watch the videos that aren't subscribed than are. All right. So if you want to learn more about this, you want to be notified whenever we post new stuff, make sure you go like and subscribe and ring the notification bell, all that good stuff. All right. Also, I have been chosen, I guess, for lack of a better word, to present at least 3 conferences this year. I'm sure there'll be more. This is just going to be in the first part of the year. But the first one I'm going to be in is a couple weeks. And that is the Massive Vision Training Expo and Training and Expo. It's mostly training. We get all the industry trainers come in. It's just outside of Kansas City. And it is a massive event. There's over 3,000 people attend every year. And, tons of different topics. There is a cost involved with it. But, as one great trainer that I've used to talk to always says, training doesn't cost, it pays, right? So the more you learn, the better you can be. And the better overall you'll be in your job, right? So I will be presenting 2 classes at Vision. So it is a hands-on lab scope class. We'll be shipping in 50 Zeus, and we'll go hands-on for 3 hours with guided component tests and the scope on the tool. That class is sold out. So if you wanted to do that one, I guess we'll try again next year. Or I will also be doing that same class in Orlando in a few weeks, like a month after that. I'll also be doing one on increasing efficiency through repeatable diagnostic workflow. So that's kind of a mouthful, but we'll be talking about creating a standardized workflow to follow. And then, like I said, I will be doing the hands-on scope class in Orlando, April 17th and 18th. And then also in Hershey, Pennsylvania, I will be doing just the increasing efficiency through repeatable workflow class, April 29th through May 3rd. I think I'm actually on the 30th, if I'm not mistaken. But yeah, that'll be a good time, all 3 of these. So if you're nearby any of those, all of them do have costs associated with them because it's like you sign up and hotel rates and stuff like that. But if you want to learn more about stuff, all sorts of diagnostic related stuff, all sorts of automotive related stuff. A lot of these have management related stuff or service writer related stuff. So check out the different websites, check out the courses. If you want to learn more, that's the place to go. And if you want to attend, hopefully I'll see you there. There's a ton of these across the U.S. and Canada, and they're pretty much all year long. Like I said, this is just the first half of the year. These are the ones I've signed up to teach at. So hopefully we'll see you there. Do you get emails from us? If you don't get emails from us, you may be missing out on things like technical focus articles, SureTrack blogs, quick tips, new product releases. They send out my schedule periodically. We're not going to spam you all the time. Maybe it's once or maybe twice a week. We're just going to send you some good information content. It's not like spammy stuff. If you aren't getting those and you'd wish to get those, click on that little QR code and it'll bring you to a sign up form and you can sign up. With that, let's get to questions. If you're on Zoom and you have a question, make sure you use the Q&A button, top or bottom of your screen. On YouTube, make sure you use the live chat. Got a couple questions on the Zoom. Let's see. Bob says, is there a handout for the class? No, not this class. For the classes that I'm doing in person, there are digital handouts for those. If you want for this, I guess it's rewatch the videos. Best we can do for that. Because we don't send out the PowerPoints as a matter of course, because copyright material. But I guess you can always rewatch the videos. Probably the best I can do for you. And then Jay says, thanks for the class. So you're very welcome, Jay. Thank you for attending, as always. And then on the YouTube, Keep It G with me says, thanks for keeping us up to date on the Zeus Plus, and you're very welcome. So with that, we've cleared the board on the questions. So thank you very much. Thank you for spending a little bit of time with me. Hopefully you got some good information about resets, relearns, calibrations, programming, coding, flashing, all that good stuff, and LIN Bus. Hopefully you'll join me next week for Body Shop Scanner Functions. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.